is. All right, let's talk to it. Today's goals. Today's goals are to apply the power theorems. We have 3 different power theorems that we're going to learn about. First one is the chord power theorem. The second one is a tangent-secant power theorem. And third being the secant-secant. If you'll notice, all 3 of these are defined or named by the segments that form them, okay? You ready? First one, chord power theorem. All right, what is the chord power theorem? Well, if A, B, and X, Y are intersecting chords on the same circle, then we can say that A times B equals X buckets. Let's try that one more time, equals X times Y. You should have a pencil out. You should have the note packet out. I'm looking at those people that I normally ask to have that out. All right, don't be one of those people that just listens to me on mute either. Make sure you have headphones. All right, so I call this the outer or the part times the part here, okay? Part times the part. Part times part. Part of your segment times part of your segment. Where A and B are part of the same segment, and X and Y are also part of the same segment. Okay, if at any point throughout this video you're confused about what I am saying, all right, make a note of it or go back and pause the video and rewatch it. Okay, hey, you know what you need to do, by the way? Oh boy, look at it, there it is. Believe you can. All right, don't forget about my cousins. Here we go. Next one, the tangent-secant power theorem. All right, remember, AB is a tangent because it hits the circle once. At one point, it's taking a tan on the circle. AD would be considered a secant because it goes through the circle. All right, so for a tangent-secant power theorem, you do A squared equals the outer piece, which is X, times the entire secant segment, X plus Y. All right, I'll label this. These are our outer segments. Outer. Oh wow, it's hard to write with this mouse. This is also an outer part. Outer. And this would be the whole secant. Okay? Holy buckets. Next one. The secant power theorem. All right? If A, B, and AC are secants on the same circle, okay, then we do A, the outer piece. Let's get that in blue. A times the whole. It's similar to the last one where the secant tangent equals X times the whole. Like that. For these again, the A plus B, that's the whole. And A and X are the outer piece. Okay, the outer piece, wow. For sure, okay. Yeah, I'm sorry about that noise there. Anytime I start recording again, it makes a weird noise. Also, the thing just froze on me. That was pretty solid, but we're going to battle through it. All right, so our last one was a secant power theorem. All right, let's talk to it. Let's try some examples here. All right, first example we're given. Here we go. Find x, y, and z. For an example 1, obviously this part A, we're just going to be finding x. Okay. First of all, we have a chord here. So we'll use the chord power theorem, where we go A times B equals X times Y. Let's talk to it. The part times the part, so 6 times 2 equals this part times this part. 3 times x, or x times 3. All right, we all know what 6 times 2 is. That's 12. And 3 times x is 3x. So you get, for x equals 4. That's it. All right, again, if at any point you want to rewind this and watch what I just did, again, feel free to do that. All right, I would want to rewatch it a couple times. I know I'm not here to answer questions. Okay, if you have a question, mark it down on your piece of paper. All right, and you can either ask someone in the Resource Center or you can ask me when I get back on Monday. Okay. Number 2, or part B. Oh my. It looks like we have a tangent line here because it hits the circle at one point. All right, and then we have a secant segment there. Okay, so we'll do the tangent secant power theorem. We'll use this power theorem where it's the tangent line squared equals the outer part of your secant times the entire secant. So in this case, y is our tangent line, so y squared equals the outer portion 2 times the entire secant segment. And I'm going to write 2 plus 16 because when we do an example in a little bit, all right, we'll be asked to find this distance here. Okay, so I want you to get in the habit of doing this. Remember though, you're not going to distribute this 2. Order of operations says we need to do whatever's in here first. Okay, so we get y squared equals 2 times 18. And if you want to skip this step, that's totally fine and do it in your head. Or y, oh boy, holy buckets, okay, I'm not doing that again. Or y squared equals 36 square root, wow, so y equals 6. Now, technically, remember, when you take the square root of a variable or of any number, it's plus or minus, right? But this is a segment. Y is a segment. So you throw out the -1. In this case, sometimes it'll work. So y is just 6. If any part of this was confusing, please go back and rewatch it. All right, please go back and rewatch that. I hope you have the sound on. If you don't, I'm not going to be happy. All right. Holy cow. All right. Oh boy. This one looks like a doozy. All right. We have a secant power theorem. We're going to use our secant power theorem. Okay. That looked like outer piece times the entire secant equals the outer piece times the entire secant. So let's talk to it. Our outer piece here is 3, and this one's a little bit strange. For our whole piece is our variable, okay? More times than not, all right, you'll be asked to find this piece here, and that'll be your variable. Okay, so let's like if that were an x, this would become 3 times 3 plus x, much like this part is 4 times 4 plus 8, the outer piece, times the whole. All right, well, that's just 3z. 4 plus 8, we know that that is 4 times 12, right? Well, 4 times 12, well, what's that? Oh, that's right. Wait, what's up? Oh, yeah. Wait, no? Yeah, 48. Are you sure? Yeah, I'm sure. Divide by 3. Are you positive? Yeah. So z equals 16. Could you go back and check your work? Yeah, of course you could. You can just plug this back in, right? Again, if any part of that was confusing, go watch it again. All right, watch it as many times as you need. I mean, if you want to just, plug in your headphones and then listen to this instead of listening to music, that's totally fine too. I can't blame you for that, but make some notes if you have a question. All right. Let's talk to the next example. Okay. I have this tangent segment PT and it measures 8 centimeters. The radius of our circle is 6. Find the distance from P to the circle. Okay. You're not going to see a lot of word problems, all right, when we do these. Okay, but let's try one because we're the best, you know. Okay, so it gives us a lot of trigger words here. All right, I'm going to call that T, and this point's going to be not T, P. Okay. How do I know to call this P and this T? Great question. It says find the distance from P to the circle. So that tells me that P is my external point out here, and it's not on the circle. It's not on it, okay? So that means this little part right here is the distance from P to the circle, so I'd call that X. All right, this is my tangent segment, so let's call that 8. All right. And it says our radius of our circle is 6, so that tells us this secant goes through our diameter. So, or excuse me, goes through our center. So if this is 6 and 6, then this whole thing is 12. So we have, excuse me, we have a tangent secant. So we got 2. Tangent squared equals the outer part of your secant times your entire piece. So let's talk to it. The outer part of our tangent squared is 8. So 8 squared equals, well, the outer part of our secant, which is X, times the entire thing. The entire secant segment would be considered X plus 12. This is what I was talking about before. All right, we're trying to find this little piece right there. Okay, I'm going to scroll down a little bit more so I have enough room here. All right, so 8 squared we know is 64. If you distribute that X, you get X squared plus 12X. Yes, we are going to have to factor this problem. Everyone loves to factor. Get everything on one side, so minus is 64. So that X squared, again, pause it if you're getting stuck, if you're getting lost for a second. It's okay to go rewatch it. X squared plus 12X minus 64 equals 0. We got to find two numbers that multiply to give us negative 64, and that'll add together to give us 12. And that is 16 and 4. Wow. So we get X. Set each factor equal to 0. X plus 16 equals 0. Subtract 16, you get X equals negative 16. Similarly, X minus 4 equals 0. Add the 4 to the other side, so you get X equals 4. All right. Now, we're looking for an outer piece here, a piece of a segment. So we can throw away, in this case, our negative. So X is 4. So the distance is 4 centimeters. And again, you could always go back and plug that back in. All right. Feel free to rewatch that part. I know I did that pretty quickly. Okay, I did that pretty quickly. Here's your homework for tonight. All right, again, I will check all the 10.8 homework on Monday. Your test is not on Friday. That's just silliness. Okay, it's next Thursday. All right, don't freak out, just relax. I'll give you your review packets on Monday as well. I hope you all enjoyed my first lesson. All right, and I hope you all are very nice to the sub. I hope to get good notes on Monday. Have a good weekend.